Welcome back. In this video, we're going to go through the examples from compound interest section in your booklet, which are on page 5. So the first one, we have Jessie investing $5,000 into an investment account that is earning 4.6% per annum compounding annually. Now, I've highlighted this compounding annually thing, and that's because in compound interest questions, it is really, really important that you identify at start the compounding period. What this means is compounding per something means how often interest is being added. So this one here is saying compounding annually. That means your interest is being added annually. This means that your N, your time periods, will be in terms of years. And it also means that your interest rate will need to match that as well. At the moment, our interest rate is per annum, which is an annual rate, which is perfect. So we leave our R as 4.6 for this one because it's compounding annually. If it was compounding by a different time period, then we would need to divide that percentage in order to get it into a percentage that matches your time periods. So let's go through here and write out what we know. We know that Jessie's got $5,000 at the start, so that's my V0. Okay, so I'm going to write that here. V0 is $5,000. I know that my R is 4.6% per annum, and it's compounding annually, so I'm just going to write R equals 4.6 per annum. Now let's go and sub these values into our rule. Now our rule format is over here on the side. I'm just going to rewrite that here, and then I'm going to go and pick up and put these numbers exactly into those spots here. So we're left with V equals 5,000, and then in brackets, so it's multiplied would be in there. You don't have to write the multiplied sign, but just know that there would be one there. You can choose to write that if you want to. And I've gone and subbed that 4.6 into the R. Now to simplify this, I'm going to take this amount that's in the bracket here and simplify it using my calculator. So let's grab my calculator out, and I will just clear what's there. We'd be going 1 plus 4.6 over 100. So that's the part that's in the bracket that I'm simplifying, which looks like this, 1.046. So I then rewrite this formula here in terms of this, which will give me V equals 5,000 multiplied by 1.046, as that's what I got on my calculator here, to the power of N. And that there is my rule for this, for Jessie's investment. Now what we're going to do with this rule is we are going to use it to calculate the value of the investment after 3 years. Now again, we identified at the start that our time periods, N, were years. So in this one here, we've got 3 years, so I'm going to let N equal 3. I'm going to use this rule here and substitute 3 into that N. So let's rewrite that down here. All right, putting it to the power of 3. Again, I get my calculator here. I've got 5,000. Where's my multiplied by 1.046 to the power of 3. All right, that's telling me at the end of 3 years, Jessie's investment will be worth $5,722.23 when I'm rounding. Now remember to round to 2 decimal places every time for money. All right, there we go. Okay, let's do the next question. Example 2, Anna invests $5,000 into an investment account that is earning 4.6% per annum compounding monthly. So you'll notice that this question is identical to the last one. Anna is investing the same amount as Jessie was. The percentage interest rate per annum is the same, but you will notice that this one says compounding monthly, whereas Jessie's was compounding yearly. So again, that compounding monthly means instead of being interest being added once a year, it's being added 12 times per year, so every single month. All right, so let's have a look at how that language changes the question. So I'll go through and I will again assign my variables. So we have our V0 is still 5,000. My interest rate is still 4.6% per annum, but it's compounding monthly. That tells me that my N, so my time periods, now are referring to months rather than years. And as such, I need to convert my interest rate to a monthly time period. So you remember from the very first video, hopefully, that to do this, you get your percentage interest rate per annum and you divide it by how many periods there are in a year. So this one's monthly. There are 12 months in a year. So we're dividing 4.6 by 12. Okay, so my rate then will just be that. And you can round it if you like. I'm just going to leave it as a fraction for now because I don't want any rounding issues to happen. Okay, I don't want to round to the as late as I can. So here's my rule here. Let's go and sub these values I have here. So I've got my V naught is 5,000. I've got my rate converted to my monthly rate now instead as required. So remember now, the N in this equation refers to the number of months, not the number of years like the last one. Okay, so everything we're doing now is in terms of whatever the compounding period is. So in setting those values in, I get this. Again, I'm going to simplify what's in this bracket here. So let's grab that calculator. To simplify what's in that bracket, I'll just clear what I've got here so we're not confused. I'll put what's in the bracket, which is 1 plus 4.6 divided by 12, which is my new rate, divided by 100. Okay, so instead of writing, I've got the bracket written like this first, which is great. You should have it written like that there, but then your next line of working should have it simplified like this. Okay, so we'll have V equals 5,000 multiplied by 1.00383 to the power of n. Now the question will generally tell you how much to round to. This one doesn't, so I've just chosen something reasonable. Okay, so I would definitely go to quite a few decimal places for these. I wouldn't just round it off to 1, okay, because you will not get the right answer if you do that. This one here, yeah, I'm going to finish it off probably where these 3 start recurring. So that will give me this one here. All right, so that is my rule for Anna's investment. Now, again, I'm going to say it again. I'm going to be like a broken record. Your N for this one now refers to months, not years. Okay, so keep that in mind when we're doing the next part, which is part B. Using the rule, calculate the value of the investment after 3 years. So in the last example, 3 years meant we would sub N equals 3 into the N value, and you'd be solving it. But remember, this one, your N refers to months. So you need to figure out, firstly, how many months are in 3 years, okay? So we've got 12 months in a year, and then you'll just multiply that by 3 to tell you how many months there are in 3 years. So I would be doing that first, okay? And that's telling me that N is going to be 36 months. So to use my rule in order to solve this part, I would be substituting the number 36 instead of my N. Okay, so that will tell me after 36 payments happening every month for 36 months, how much is the value of the investment. That's giving me an answer of $5,738.36. Okay, and remember your rounding, 2 decimal places always, okay, for money. All right, part C, compare Jesse's balance and Anna's balance at the end of the 3 years. Whose account is a better investment and why? So I've popped here Jesse's and Anna's values. So there was Jesse's from before, $5,720.23. So they've both invested the same amount of money at the same annual interest rate, but Jesse's was annually and Anna's was monthly. And when I say monthly and annually, I mean the bank is adding interest 1 time per year for Jesse and is adding it 12 times per year for Anna. Okay, let's see what the best outcome is for these 2 girls. All right, which one there has the most at the end of the 3 years? You should be able to see that Anna has the most at the end. So basically, we can summarize and say Anna's investment earned more than Jesse. Can we think of a reason why that would be? Okay, Anna's bank is adding interest more often, and because compound interest, you are earning interest on top of the previous balance of your last, your final balance of your previous month, and then they calculate interest again, and they keep on doing it like that. So the more often you are calculating and adding interest, the better off it is as an investment. Okay, so for this one here, they have the same investment, the same interest rate, but Anna earns more as her bank calculates and adds the interest more often. Okay, so more compoundings, better often is an investment. If you were borrowing the money and you were having to pay this back to a bank though, obviously having more compoundings means you'd be having to pay more to a bank. Okay, so if you've got a question like this, Which account is better? Just keep in mind, if it's an investment, you want to earn more money. So more compoundings is great. If it's a loan though, you don't want to pay much money to the bank. So less compoundings would be better if you're looking at a loan instead. All right. All right. Example 3, Betty has an investment which follows the rule Vn equals 16,000 multiplied by 1.04 to the power of n, where Vn is the value of the investment after n years. So again, we're interpreting for this question. We're looking at the rule and hopefully understanding what means what in this, and we'll try and answer these questions. How much did Betty initially invest? Look through and remember to make the links between the rule and what we've got in the question. You can see that V0 is this here. You can see that this bracket here has equated to 1.04. So my rate isn't 1.04. We found the rate using, we had the rate and calculated this whole thing and got 1.04, but it isn't the rate, okay? We could use it to help us find the rate, but at the moment we still don't know what R is, okay? So we can hopefully see V0 is 16,000. So I'm going to write that for part A. What is the interest rate for the investment? Now, as I said, it's obviously got something to do with this 1.04 part here, but that doesn't mean it's the interest rate. This is what this bracket will equate to. So I'm going to get what's in this bracket, 1 plus R on 100, and I'm going to let what's written in this spot here equal what's written in the bracket here. Okay. So I've got this. 1.04 equals 1 plus R on 100. So hopefully you can see that's how that these two are linked. Okay, once you solve this, you get what's in this equation here. Now you can see here we've only got one unknown thing, so we'll grab our calculator and we'll put this into solve and we'll find out what our rate is. Okay, once you do that, you should be getting a rate of 4. That's telling me that my annual interest rate is going to be 4% per annum. How many years does it take for the value of the account to be $21,000? Again, I will use the rule for this. So what am I solving? It's asking how many years does it take? So am I solving Vn or am I solving n? How many years does it take? Now that's going to be my n, my number of time periods. And I'm told that the value of the account at this time is $21,000. So $21,000 will go into where your Vn is. Okay, and then we will solve n. All right, grab your calculator again, pop this into solve, remembering that that n is to the power of. It's so easy to think it's a multiplier, but no, it's the power of n. Put that into your calculator like this, and you will be getting an answer of 6.93 years. Now, I've rounded this one up to 7 years, and the reason for that is that interest is being added every year. So I had to round it up to the next year, okay, because interest doesn't get paid at 0.93 years. It's telling me here that it's doing it annually. Okay, so I have rounded up here. All right, last one. Let's see if we can get it done in time. An investment account begins with $20,000, and in the space of 7 years, it grew to $25,000 with the account compounding monthly. Determine correct to 2 decimal places the interest rate per annum. Again, let's go through and highlight the things we know. It's starting with $20,000, so that's my V0. It's telling me that the final value after 7 years is $25,000. We don't, after 7 years. So we know the value after 7 is 25,000. Okay, we also know that it is compounding monthly. So n refers to number of months. So in order to find our n value here, n is not going to be 7. It's going to be 7 multiplied by 12 because there's that many time periods happening in that 7 years. Okay, so that would give me, for my n value, 7 years times 12, which gives me 84 time periods in that time. Okay, so I've got a V0, a Vn, and an n. The only thing that I'm missing is my R, and that's the thing I want to know. Let's go and sub these values in. Okay, by subbing those values in that I know, that is going to allow us to solve R using our calculators. So I put that big equation in, and this is the answer that I get. I get 2 solutions. One's negative 200 and one's a positive number. Always ignore the negative solutions. So this one here is giving me a rate of 0.266. Okay, so 0.266, that's percent per month. We multiply that by 12 to give me the percentage per annum. Okay, go and try those questions now from the exercises.